Good morning everyone, and welcome to today's very short and sweet worked exam answer video. Now I've chosen this particular multiple choice because we're going to need to do a calculation involving Avogadro's constant, and I don't feel like this sort of question involving Avogadro's constant gets enough airtime perhaps when we are practicing amount of substance questions right at the very start of year 12. So I've chosen to have a look at this one. There's a few things where you might get tripped up in this question, and as always with AQA, the multiple choice answers are answers that you will get partway through the calculation. So it's really important with calculations that you are happy that you have finished your calculation and you've got your final answer before you check the options that are available to you, because as you will see when I write down on my methodology, some of these answers will appear further up the calculation. So I'll get my word answer done now and I'll come back to you to explain. Okie dokie, so we're working out how many protons there are in 6 grams of nitrogen gas, and then we're given the value for Avogadro's constant, which is 6.022 times 10 to the 23 moles to the minus 1. Now, the first thing that will catch some students out is not remembering that nitrogen is a diatomic gas. So the formula for nitrogen gas is N2, and therefore when we work out the moles of the nitrogen, we're going to do the mass divided by the MR. So we're going to add the nitrogen's relative atomic mass twice. So 14 add 14 is 28. 6 grams for the mass divided by 28 gives me the number of moles. Now, there is a second equation involving the number of moles, where the number of moles is equal to the number of particles divided by Avogadro's constant. So in rearranging that, I can figure out the number of molecules of N2 that we have in that 6 gram sample of nitrogen gas by doing the number of moles that I've just deduced times by Avogadro's constant, which is often given the letter L as shown there. If I then times them together, that gives me how many molecules we have in our sample. So 1.29 times 10 to the 23 molecules, which as you can see would be answer A on the list. So some students would get that far, see that they've got an answer that's in the list and think that that therefore must be the answer. It isn't, because we've worked out the number of molecules at this point, and the question is asking me about how many protons there are. So how many protons would there be in one molecule of N2? 14, because again, if there's 2 atoms of nitrogen and each atom has 7 protons, the number of protons in one molecule is 14. Then we can figure out the total number of protons by doing the number of molecules times by 14. If you didn't know that it was diatomic, again, you were going to get caught out because you would have done the number of protons in one nitrogen atom as 7, and then again ended up going wrong at that point. Alternatively here, rather than going straight from molecules to protons, we could have gone to atoms first. So I could have changed the number of molecules of N2 into the number of atoms of nitrogen. There are 2 atoms per molecule, so if I times this number of molecules by 2, that would have got me the number of atoms. Then I could have times that by 7 to get the total number of protons. And of course, whether we times it by 2 and then by 7, or whether we times it by 14, we're going to get to the same answer, which is here. 1.81 times 10 to the power of 24 protons. So the answer is C. Hopefully that's clear for you all, guys, but anything that I've said that is not clear, please do, as always, get in touch, leave a comment, send me an email, whatever is most comfortable for you. Thanks so much for watching.